Myself, Munish Sethi, lecturer at GPCG Jalandhar. So, बच्चों, today our topic is successive differentiation. You already know about differentiation. The process of finding differentiation of a function again and again is called successive differentiation. Successive differentiation, that is, if y is a function of x, any variable x, then its differentiation of y with respect to its x, that is called the first derivative of y with respect to x, it is denoted by f dash x or y1 or another variable y dash x. These are the 2-3 representation of first order derivative. If we differentiate again this first order derivative, that is d dx of dy by dx is equal to d2y by dx. This is the second order derivative of y with respect to x, and it is represented by y2 or y double dash x. So, repeating this again and again, in general dn y by dxn, this is the derivative of, that is the nth order derivative of y with respect to x, and it is denoted by yn or ynx. So, this concept can be easily understood with the help of some illustrations or some examples. Let us take first example. If y is a function of y is equal to 4x cube plus 4x plus 7, then find y3. Solution. Now, given y is equal to 4x cube plus 4x plus 7, differentiate with respect to x both sides. dy by dx is equal to 12x square, 4x, the differentiation of 4x is 4 and the differentiation of 7 is 0, because the differentiation of constant is 0. Similarly, again differentiate both sides. d2y by dx square that is y2, it is equal to 24x, as you know about xn, differentiation is nx n minus 1, plus the differentiation of constant 4, that is again 0. Again differentiate with respect to x, both sides, we get y3 is equal to 24, because the differentiation of x is equal to 1. So, here we use the formula d dx of x raised to power n is equal to nx n minus 1. So, in this way you can find out the triple order derivative, or however if you want to find out the fourth order derivative, then that differentiate again y3, you can get y4, the differentiation of 24 is equal to 0. Now, let us take another example, some difficult one. If y is equal to sine of cos x, then find y2 then find y2 at x equal to pi by, at x equal to then find y2 at x equal to pi by 4, pi by 2. You want to find out y2 at x equal to pi by 2. Solution. So, given y equal to sine of cos x, so you differentiate with respect to x, y1 is equal to the d dx of sin x is equal to cos x into d dx of that angle, that is cos x, so y1 is equal to, therefore, y1 is equal to cos of cos x, d dx of cos x is equal to minus sin x. Now, again differentiate with respect to x, we have y2 is equal to, now here you apply, you see that we have two function, product of two function. So, we apply u into v method. So, cos u, this is u and this is v. So, u d dx of v, you can take minus common, d dx of sin x plus sin x d dx of cos x. So, cos of cos x d dx of sin x, you know that it is equal to cos x plus sin x. Now, d dx of cos x, it is equal to cos theta, d dx of cos theta is equal to minus sin of cos x into d dx of angle cos x, that is equal to again minus of sin x, bracket close. So, you see that we apply u into v formula. Now, we want to find y2 at x equal to pi by 2. We put x is equal to pi by 2 in equation number 1. Therefore, y2 at x equal to pi by 2 becomes minus. You see that cos of cos pi by 2, you know that cos 90 degree it is equal to 0. Cos pi by 2 it is again 0, plus sin pi by 2 you know that 1, minus minus plus sin of cos pi by 2 0 into sin 0 is 0. You see that you can get 0. So, the double derivative of cos of sin of cos x at x equal to pi by 2 it becomes 0. Now, let us take another example of the parametric forms, example 3. Now, let us take another example of parametric form, that is if x is equal to a, theta plus sin theta, y is equal to a, 1 plus cos theta. Now, to find y2 or prove that y2 is equal to 1 over 4a secant 4 theta by 2, secant theta by 2 whole power of 4. You see that the function is in parametric form, that is x is equal to a theta plus sin theta. This means dx by d theta, that is the differentiation with respect to theta, a is constant, the differentiation of theta is 1 and the differentiation of sin theta is cos theta. This is number 1. Similarly, y is a 1 plus cos theta and its differentiation is dy by d theta, a constant, the differentiation of 1 is 0 and cos theta is minus sin theta. This is number 2. Now, you want to find out y2. So, first of all we find out dy by dx, that is y1. Therefore, dy by dx is equal to dy by d theta into d theta by dx. It is equal to dy by d theta is minus a sin theta divided by a into 1 plus cos theta. Now, we apply the formula A on cancellation A, sin theta, the formula trigonometric formula, sin theta is theta sin theta by 2 into cos theta by 2. So, 1 plus cos theta it is equal to 2 cos square theta by 2. So, after cancellation cos theta cancel each other. So, we left with the minus tangent theta by 2, minus tangent theta by 2. You see that minus tangent theta by 2. Now, we want to find out y2. So, differentiate again with respect to x. Therefore, d2y by dx square is equal to minus tan theta differentiation is secant square theta by 2 into 1 by 2 into d theta by dx, d theta by dx. So, you see that minus 1 by 2 secant square theta by 2. So, d theta by dx you know from equation number 1 d theta by d2 x is a 1 plus cos theta. This is equal to minus 1 over 2a secant square theta by 2. 1 plus cos theta is again 2 cos square theta by 2. So, after solvation you are going to get minus 4 over secant square for theta by 2. You can check it. D2 by dx square, it is equal to minus 1 by 4 secant 4 theta by 2. So, let us take another example, just some typical example, another example of successive differentiation. If y is equal to e raised to power m sin inverse x, if y is equal to e raised to power sin inverse x, and prove that 1 minus x square y2 minus x y1 is equal to m square y. Now, you want to prove this. You have given y is equal to e raised to power m sin inverse x. So, you have given y is equal to e raised to power m sin inverse x. You see that we want to prove that 1 minus x square into y2 minus x y1 is equal to m square y. So, we first of all want to find out y1 and y2, that is the first order derivative of y with respect to x and the second order derivative of y with respect to x. So, make it as number 1. So, differentiate 1, you see the differentiate 1 with respect to x, you can get y1. y1 is equal to the differentiation of d dx of e power m sin inverse x. So, e power sin inverse x, e power x is differentiation is e power m sin inverse x, e power x differentiation is e power x into d dx of m sin inverse x. This means y1 is equal to e power m sin inverse x. So, d dx of m into sin inverse x, m is constant, d dx of sin inverse x is 1 over 1 minus x के square root. So, we know that e power m sin inverse x is equal to y divided by 1 minus using 1. Use 1, equation number 1, e power m sin inverse x is equal to y. Now, cross multiply 1 minus x square y1 is equal to my. So, this is number 2, make it is 2, this is 3. So, differentiate 3 with respect to x. So, you can apply on the left hand side your product of two function, you can apply u into v formula. Here this is u and this is v. So, u d dx of v, y1 differentiation is y2 plus y1. So, d dx of 1 minus x square root is equal to 1 by 2, 1 minus x square to 1 by 2 minus 1 into minus 2x. It is equal to m constant. The differentiation of y is y1, first order derivative. This means 1 minus x square into y2 you see that 2 to cancel each other, we left with the minus x y1 divided by 1 minus x square is equal to m. Now, the value of y1 is from using equation number 2. The value of y1 is using 2. So, on cross multiplication we get 1 minus x square y2 minus x y1 is equal to m square y. So, hence proof. So, with the help of double differentiation you can prove this equation very easily. So, let us take another example of a similar kind. Let us take another example of a similar kind, but someone different equation. If different function, if y is equal to tangent inverse x the whole square, then prove that prove that 1 plus x square whole square y2 plus 2 times x into 1 plus x square y1 is equal to 2. That is, if y is equal to tan inverse x whole square, prove that 1 plus x square the whole square y2 plus 2x 1 plus x square y1 is equal to 2. So, similarly as in the previous example we find out y1 y2, in the similar way we can find out y1 and y2 easily. So, given this is number 1. So, differentiate 1 with respect to x. We have y1 is equal to, now here we apply the formula tan inverse x whole square, that is x raised to power n, that is equal to 2 times tan inverse x 2 minus 1 into ddx of tangent inverse x. So, this means y1 is equal to 2 times tan inverse x. The differentiation of tan inverse x is equal to 1 over 1 plus x square. You know that from the previous topics that the differentiation of tangent inverse x is equal to 1 over 1 plus x square. This means 1 plus x square into y1 is equal to 2 times tangent inverse x. This is number 2. Now, differentiate 2 again. To find y2 we have to differentiate with respect to x. We have, so on the left hand side you have again 2 function, product of 2 function, that is we can apply the formula of u and v, u into v. Here u is this and v is this. So, u into v on the left hand side you can apply the u into v formula u. The differentiation of y1 is again y2. Differentiation of y1 is the first order derivative and its differentiation is becomes y2 plus y1 into ddx of 1 plus x square equal to 2 times divided by 1 plus x square, because the tangent inverse x again the differentiation of 2 upon x square. So, 1 plus x square y2 plus into y2 plus the differentiation of 1 is 0 and x square is 2x y1 is equal to 2 times 1 plus x square. On cross multiplication 1 plus x square, we get here 1 plus x square whole square into y2 plus 2x y1 is equal to 2. Hence, you see that into here we have miss, that is 1 plus x square. So, you see that we get the required result. So, in this way you can apply successive differentiation. And now let us take another example that contain the third order derivative and also contain the exponential function. That is, if y is equal to a e power x, b e power 2x or c e power 3x, prove that y3 minus 6 y2 plus 11 y1 minus 6 y is equal to 0. So, you see that we have to prove a result where that contain third order derivative, second order derivative, first order derivative, and the result doesn't contain the constants a, b, c that is in the statements. So, we can apply the method to eliminate a, b, c from the given result with the help of derivatives. So, solution, you are given y is equal to a e the power x, b e power 2x, c e power 3x. This is number 1. You can differentiate 1 with respect to x. You can y, the differentiation of y is y1. Differentiation of aex is equal to aex because a is constant and the differentiation of e power x is e power x, plus b e power 2x because the differentiation of e power 2x is e power 2x into 2, plus c into differentiation of e to the power 3x e to the power 3x into 3. So, you make it as equation number 2. Now, we have to eliminate a, b, c. Now, we eliminate a, b, c successively. So, subtract 2 minus 1 equations, we get, if you subtract 2 minus 1, that is the equation number 1 from equation number 2, we get y1 minus y. You subtract it, the first term a e power x, it cancel each other. The 2b subtract from b, that is b e x, we left with the 2c e power 3x. This is number 3. Now, you differentiate again because you want to prove the result that contain y3 and y2. So, do you differentiate y3 or equation 3 with respect to x? You can get y1 differentiation is again different with respect to x is y2 and y differentiation is y1. The differentiation of bex is again bex plus differentiation of e to the power 3x is e power 3x into 3 into 2c is equal to 6c. Now, make it as number 4. Now, we want to eliminate b. So, again we want to eliminate, you can see that 2b minus b is power 2x, we left with 2 power 2x. Here we have this. Now, differentiation, it is become 2b e to the power 2x 6c. Now, we want to eliminate b. For that, we subtract equation from equation number 4 2 times equation number 3. You see that you see that when you subtract equation number 3 into 2 time from equation number 4, you see you can find out y2 minus y1 minus 2 times y1 minus y is equal to